On June 11, 2026, a small group of researchers uploaded a paper to a public research archive that most people will never read. No press conference. No dramatic announcement. Just a quiet document sitting on a server. Contained a single number that shouldn't exist. 5.11 micrometers. That number is a wavelength of light. Right now, it is the reason a handful of the most experienced planetary scientists on Earth are staring at their screens. They are running the same calculation over and over. They are hoping they made a mistake. They haven't found evidence of a known chemical. They haven't matched it to anything in any database. Not any textbook. Not any spectrum ever recorded from any planet, moon, comet, or distant alien world discovered so far. The James Webb Space Telescope found something on the surface of Pluto. It found the same thing on Saturn's giant moon Titan at the exact same time. It is a signature for something that has never been seen anywhere in the known universe. Not on Earth. Not on Mars. Not on any of the thousands of exoplanets Webb has already studied. Nowhere. Think about what that actually means for a second. We have identified the chemical fingerprints of oxygen in the atmospheres of planets orbiting other stars hundreds of light years away. We found sugar molecules drifting in interstellar gas clouds. We found the building blocks of life itself in ice sitting outside our own galaxy. Chemistry at this point is one of the things astronomers are genuinely good at identifying from a distance. This signal still doesn't match anything on the list. This is the story of what Webb actually saw. It's the story of why it landed like a quiet gut punch in the planetary science community before it landed as excitement. It's the story of why the answer to what is it might still be years away. Stay with me. The deeper you go into this one, the stranger it gets. To understand why this discovery hit so hard, you first need to understand what Pluto was supposed to be. For most of the 20th century, Pluto was barely a footnote. It was a fuzzy dot discovered in 1930. It was too small and too far away for any telescope on Earth to make out real detail. Even the most powerful ground-based observatories could only resolve it as a smudge of light. A handful of pixels at best. It sat at the edge of what we considered the solar system. It was filed away as a frozen, forgotten leftover. Scientists assumed it was geologically dead. A plain ball of ice with nothing interesting happening on its surface. Waiting quietly in the dark for nobody to ever visit. Then in July of 2015, NASA's New Horizons spacecraft screamed past Pluto after a 9-year, 3 billion-mile journey. In a matter of hours, that entire assumption collapsed. Pluto wasn't dead. It had mountains made of water ice. Some of them were as tall as the Rockies. It had a heart-shaped plain of frozen nitrogen so smooth and young-looking that it appeared to be actively resurfacing itself. Glacier-like flows of ice were slowly reshaping the ground in real time. This was happening on a world barely a fifth the size of Earth, sitting nearly 40 times farther from the sun. Floating high above it all was something nobody expected to find on a world that small and that cold. Stretched more than 185 miles into Pluto's thin atmosphere. It formed dozens of distinct bluish bands that scientists still don't fully understand. That haze turned out to matter more than anyone initially realized. Researchers studying New Horizons data back in 2017 had predicted, based purely on theory, that this haze should make Pluto unusually bright at certain mid-infrared wavelengths. At the time, no existing instrument was sensitive enough to actually test that prediction. It sat on the shelf for years, an unconfirmed idea waiting for better technology to catch up. Years later, the James Webb Space Telescope came online. It was finally able to separate Pluto's faint signal from that of its large moon Charon. No previous telescope had been sensitive enough to do that cleanly. The two worlds sit so close together in the sky that their light constantly bled into one another in older data. Researchers confirmed that this haze isn't just a pretty visual detail. It actively drives Pluto's climate. It controls how the tiny world heats and cools despite sitting on average 39 times farther from the sun than Earth does. One astronomer who led that analysis described discovering this connection as one of those rare moments in planetary science. A years-old theoretical prediction had gotten confirmed almost exactly as written. She called the experience exciting enough to feel lucky about. That was already a strange enough year for Pluto. Then came June of 2026. Here's how the new discovery actually happened. It's worth understanding the method because the method is part of why this is so unsettling. Every single chemical compound in the universe absorbs light at very specific unique wavelengths. Every molecule, every element, is essentially a fingerprint, as distinct and individual as the lines on a human hand. Water absorbs light at one set of wavelengths. Carbon dioxide absorbs it at another. Methane absorbs it at another still. Astronomers have spent decades cataloging these fingerprints in laboratories on Earth. They've built up a reference library covering thousands of known compounds. That way, when a telescope points at a distant world, scientists can compare what they see against that library and get a match. Astronomers don't send a spacecraft to scoop up a sample when they want to know what a distant world is made of. They study the light bouncing off its surface or shining through its atmosphere. They look for tiny dips in that light. These dark lines in the spectrum are called absorption lines. Each one corresponds to a wavelength that a specific known chemical is known to soak up. Find the dip. Match it to the fingerprint. Now you know what's there. This is how astronomers have identified oxygen in exoplanet atmospheres. It's how they've found organic molecules in ancient galaxies and thousands of other cosmic ingredients, all without ever physically touching the object being studied. Nothing but starlight and a very precise instrument capable of splitting that light apart. A team of researchers set out to re-examine Webb's archived data on Pluto and Titan. They focused deliberately on a narrow slice of infrared wavelengths that previous studies had mostly skipped over. It wasn't hard to look at. Nobody had simply prioritized it yet. It was buried among thousands of other more immediately interesting wavelengths already claimed by other research teams. What they found was sitting quietly in data that had already been collected and sitting in storage for months. Some of it dated back to observations from 2023. They found a distinct, unmistakable dip in the spectrum at around 5.11 micrometers. Not once, not on one world, on both. They checked it against every published planetary spectrum they could find. They cross-referenced decades' worth of cataloged absorption lines from ice's minerals and organic compounds recorded across the solar system and beyond. Nothing lined up. The researchers wrote in their own paper that they could not find any documented band anywhere in the existing scientific literature that corresponds to the exact location of this absorption on Titan and Pluto. In plain language, this fingerprint doesn't belong to anyone in the database. It's not that they found something rare. It's that they found something with no name. Here's the detail that turns this from a curious footnote into something scientists are calling genuinely baffling. Titan and Pluto are in almost every meaningful way completely different worlds. Titan is Saturn's largest moon. It is bigger than the planet Mercury. It is wrapped in a thick hazy atmosphere 50 times denser than Earth's. It is the only place in the entire solar system besides Earth known to have liquid rivers, lakes, and seas sitting openly on its surface. On Titan, that liquid isn't water. It's methane and ethane. It stays liquid at temperatures that would instantly freeze anything on Earth solid. It cycles through an entire weather system of clouds, rain, and evaporation that mirrors Earth's own water cycle almost eerily closely. Just built from entirely different chemistry. Pluto, meanwhile, is barely half of Titan's size. It sits roughly 4 times farther from the Sun. It is a comparatively simple, frozen, airless-feeling world by comparison. It has none of Titan's dramatic weather or liquid surface features. No rivers, no rain, nothing resembling an active hydrological cycle of any kind. 2 worlds that different, separated by hundreds of millions of miles and orbiting entirely different planets, shouldn't share a surface chemistry fingerprint that exists nowhere else in the known universe. There's no obvious shared origin story that would explain it. Titan and Pluto didn't form in the same place. They didn't experience the same history. They aren't exposed to remotely similar amounts of sunlight radiation or temperature. Yet here it is showing up in both, at nearly the identical wavelength. As if 2 strangers on opposite sides of the planet turned out to be carrying the exact same rare fingerprint. The researchers didn't stop at simply confirming the signal was real. They wanted to know exactly where it was coming from. Was this mystery substance floating in the thin gas surrounding these worlds? Or was it sitting directly on their frozen ground? This question matters enormously. A gas and a solid imply completely different formation processes and completely different implications for what this substance actually is. To test this on Titan, they compared the signal measured at the center of the Moon's visible disk against the signal measured near its edges. If the absorption were coming from gas in the atmosphere, it should have looked stronger toward the edges. That's where starlight has to travel through a thicker slice of atmosphere to reach the telescope. It's a well-established technique astronomers have relied on for years to distinguish surface features from atmospheric ones. Instead, they found the opposite. The signal was weaker at the edges and stronger at the center. That result pointed in one direction only. Whatever this substance is, it isn't drifting in the sky above these worlds. It's sitting directly on the surface, embedded in the ice itself, exposed to the vacuum of space and whatever radiation happens to reach it. The deeper the researchers looked, the odder the details became. On Pluto, the absorption line was roughly 3 times wider than the one found on Titan. This suggests the mystery substance is significantly more abundant or exists in a noticeably different physical form on Pluto's surface. On Titan, it wasn't even spread evenly. The signal showed up stronger on the Moon's trailing hemisphere. That's the side that faces backward as Titan moves along its orbit around Saturn. It was weaker on the leading side facing forward. That kind of lopsided distribution usually means something environmental is actively shaping where this substance can form or survive. Radiation exposure, particle bombardment, temperature differences between the two hemispheres, or some combination researchers haven't identified yet. This isn't a static uniform coating laid down once billions of years ago and left untouched ever since. Something out there is actively controlling where this unknown material builds up and where it doesn't. Right now, in an ongoing process nobody has mapped. So what could it actually be? The honest answer is that nobody knows yet. The researchers themselves are careful not to overclaim. Their leading tentative guess is benzene. That's a fairly common ring-shaped hydrocarbon molecule found in plenty of places across the solar system. It might be combined with some other still unidentified compound in a way that shifts its usual fingerprint into unfamiliar territory. Molecules mixed together can sometimes absorb light differently than they would on their own. Another possibility on the table is a specific frozen form of acetylene, or a compound called ketene. Both are the kinds of complex carbon-based ices that can slowly assemble on extremely cold sunlight-starved surfaces over unimaginable spans of time. They build up molecule by molecule as simpler compounds get bombarded by faint radiation and slowly stitched into more complex chains. Every single one of these is a guess, not a conclusion. The paper hasn't even completed peer review yet. It's a first flag planted in freshly examined data, not a closed case. The researchers know it. That unresolved uncertainty is exactly why the tone inside parts of the planetary science community has shifted. Excitement has turned into something closer to quiet, controlled unease. This isn't a situation where scientists get to comfortably announce a new discovery and move on to the next project. Two very different worlds hundreds of millions of miles apart appear to share a chemical signature nobody can explain. This is happening with a telescope specifically built to catch details exactly like this one. The honest, sober answer researchers have to give right now when asked directly what it is comes down to one sentence. We don't fully know what we're looking at. It's worth clearing up what that unease actually looks like in practice. NASA in panic isn't literally what's happening inside a control room somewhere. Nobody is sounding alarms or evacuating buildings over an absorption line. What's actually happening is quieter and in its own way more interesting. A slow-building unease is spreading through conference calls, peer review comments, and late-night email chains between specialists. Not through anything resembling a headline. Researchers who study planetary chemistry for a living spend entire careers building a mental map of what belongs where. Which molecule goes with which world. When a result shows up that refuses to fit anywhere on that map, the discomfort is real. Even without a single siren attached to it. Here's why that specific kind of not knowing matters so much more than it might first seem. Webb wasn't guessing when it caught this. It's specifically designed to be extraordinarily sensitive to faint infrared signals precisely like this one. It was engineered from the ground up at a cost of billions of dollars and decades of development. The explicit goal was to pull exactly this kind of subtle chemical fingerprint out of the noise of deep space. When an instrument built with that level of precision returns a result nobody can explain, the instrument isn't the problem. The gap is in what we know, not in what Webb saw. That gap sits in the what we know column instead of the our equipment is unreliable column. That's precisely the kind of gap that tends to keep scientists up at night. It means there's a piece of basic chemistry sitting right there on two worlds we've already visited and studied for years. Our entire existing understanding simply failed to predict it. So what happens next? For now, mostly waiting. And more looking. Researchers are already requesting additional Webb observation time to gather cleaner, more targeted data on this exact wavelength. They're hoping a sharper signal will help narrow down the list of candidate molecules. Other teams around the world are almost certainly rechecking their own archive data right now. They're hunting for the same 5.11 micrometer dip on other icy worlds nobody has thought to check yet. But the mission that might actually deliver a definitive hands-on answer is still years away. NASA's Dragonfly spacecraft is a nuclear-powered drone-like rotorcraft. It's designed to fly directly through Titan's thick atmosphere and land at multiple sites across the Moon's surface. It's currently scheduled to launch no earlier than 2028. Arrival at Titan is planned for the mid-2030s. Dragonfly will carry its own onboard spectrometer. It will be capable of directly sampling and analyzing the chemistry of Titan's surface in a way no telescope, no matter how sensitive, can match from hundreds of millions of miles away. If that instrument can positively identify whatever is producing this 5.11 micrometer signature on Titan, it would very likely help settle the question of what's sitting on Pluto's surface too. Both worlds appear to be showing the same unexplained fingerprint. There's a broader pattern worth noticing here too. This isn't the first time in the last few years that the region around Pluto has produced a result that broke expectations. Around the same time this study was circulating, other researchers were studying a completely different icy object out past Pluto's orbit. They reported evidence that it appeared to have an atmosphere. Current models say that shouldn't be physically possible for an object that small, that cold, and that far from the sun's warmth. Temperatures out there sit low enough that most gases should simply freeze solid onto the surface rather than hang in the sky. Different object, different team, different month. Same basic pattern. The outer solar system keeps returning results that don't fit the models we built to explain it. Piece by piece, the picture emerging from that region isn't one of frozen, predictable simplicity. It isn't the sleepy graveyard of leftover ice most people still imagine when they picture the edge of the solar system. It's one of active, ongoing chemistry. This is happening in places we assumed were far too cold and far too dead for anything interesting to still be occurring. On timescales and through processes we're only beginning to understand. Here's the honest, unglamorous truth. Humanity may already know right now in 2026 that something chemically unprecedented exists on two worlds at opposite ends of the outer solar system. We may not get a confirmed answer for what it actually is until sometime in the mid-2030s. That's when a small robotic helicopter finally sets down on Titan's frozen hydrocarbon-soaked ground and takes a direct look for itself. For close to a decade, this mystery substance will just sit there undisturbed. Exactly as it has for who knows how many millions of years. We will slowly build the one machine capable of actually reaching out and touching it. There's something quietly humbling in that timeline. We like to imagine scientific discovery as instant. A telescope sees something strange. Within days, brilliant minds crack the code and give it a name. Roll credits. Move to the next mystery. The truth most of the time looks nothing like that. It looks like this. A faint dip in a spectrum buried in data that sat unexamined for months. It was found almost by chance by researchers looking somewhere previous studies had skipped. Years of careful, unglamorous patient work will follow before anyone can say with real confidence what it actually is. Real scientific mystery doesn't resolve on camera in a single dramatic reveal. It resolves slowly, in the space between one publication and the next. In observation proposals and telescope schedules and spacecraft that won't even launch for another 2 years. The rest of the world moves on to other headlines entirely. That patience is exactly why this story matters right now while it's still unresolved. However many years it takes to get a real answer, every single person who understands what Webb actually found gets to sit with a genuinely rare kind of question. What is sitting on the surface of two different worlds hundreds of millions of miles apart that no laboratory on Earth has ever managed to reproduce or identify? Nobody can Google the answer. Nobody has quietly leaked it. It simply isn't known yet. Not by anyone. Not anywhere. It won't be for years. For the moment, everyone watching this is looking at the exact same open question the world's leading planetary scientists are staring at too. Pluto was demoted from planet to dwarf planet back in 2006. Plenty of people dismissed it as a frozen afterthought not worth taking seriously anymore. It became a punchline in astronomy jokes for the better part of 2 decades. 2 decades later, it's sitting at the center of one of the strangest open chemistry mysteries in modern astronomy. It's holding a secret that our most advanced space telescope can see clearly but cannot yet name. Somewhere out there in permanent twilight on a surface where sunlight itself arrives thousands of times weaker than it does here on Earth, something is quietly sitting in the ice, waiting for humanity to finally figure out what to call it.